there's quite a bit we'll get through hopefully today. So let's just do a quick recap as to the differentiation process and what we can do with it. We know fx equals 3x squared, take away 4x, when x equals 1. How do I work out the y coordinate? So y equals f of 1. Substitute x equals 1 in there, so you get 3 times 1 squared, take away 4 times 1. So that gives us minus 1. So we've got coordinate 1, minus 1. If you then want to work out the gradient of the tangent, what do? dy over dx. dy over dx. How do you write that in fx notation? F prime x is your dy over dx. And what do you get when you differentiate it?
6x
minus 4. So when x equals 1, f prime of 1 gives you what?
2.
So 6 times 1 take away 4 and you end up with 2. We can now put that into an equation where y minus y1 equals mx minus x1. Substitute those values in and out comes y equals 2x minus 3. Okay, and we can verify that by this graph there. So you've got y equals 2x minus 3, and that's what we have. Yeah, and there's the equation of the tangent. We can see that there. Y equals 2x minus 3. Okay. All right. What I want to do is take a step back. Whoops. Right. What I want to do is take a step back and look at the differentiation process. So far, I've just told you, you take the power, bring it down, take 1 away from the power. What we want to do is go back and understand how Newton came up with these differentiation principles in the first place. Okay? And how is it that we can say when you differentiate, you don't get, we're saying the gradient of the tangent is the gradient of the curve at that point. It's not an approximation, it's the exact gradient. Okay, how comes that's true? In order to answer that question, let's take a scenario. Pretend we want to estimate the gradient around x equals 1. We just want to estimate. Okay, we don't know any differentiation. What can we do? Yes?
Gradient of the tangent to the curve means they assume the y change in y when you change in it.
Okay, so what Sierra said is if you look at the change in y over change in x between 2 points, so if I just do something like that, and if I were to work out the gradient of this slope, okay, then what I could do is just basically take 2 points near this curve, near this point x equals 1, and make an estimate of the gradient of the function by looking at the gradient of the tangent of the straight line. Would you agree? Yeah, so we know about 2 points. We know it will be y1 take away y2 over x1 take away x2. Now, for argument's sake, what would be better if we take a big distance away or a small distance? The smaller distance, isn't it? Yeah. The smaller the distance, the more accurate our result. Would you agree?
Yes.
Right. Now, just for simplicity, what I'm going to do is just to use integers. I'm going to just take this at 2, just for now. Okay? Okay, just to illustrate the point while we do our calculations. Okay, that we look at a change in y over change in x between 1 and 2 for this curve. Okay, so why don't I put this in? I'll stick that in there because that's what we'll be considering. Okay, and we can see the gradient is 5 straight away. Okay. Now let's just use some algebra and see if we can come out with something. This coordinate here is when x equals 1, we had y equal minus 1. Is that correct?
Yes.
That's point A. Point B, when x equals 2, y equals 4. Agree? So the gradient m, we know from GCSE, is the change in y over change in x, which is y2 take away y1 over x2 take away x1, which in this case will be 4 minus minus 1 divided by 2 take away 1 which is 5 over 1, which gives us a gradient of 5, which is correct. Is that okay so far? Alright. Let's now use some algebra. So instead of using, or before we move on to algebra, we can just switch to some fx notation. So what I could do is this point here, my y2 is really f of 2 take away f of 1 divided by the change in x, which is simply 2 take away 1. And that gives me the same result. Do you agree? Yeah? When I put x equals 2 into my function, fx, yeah, so fx equals, what was it, 2x squared? 3x squared. Take away 4x. So what I'm saying is, instead of writing y2, which we know is 4, I know I get 4 when I put x equals 2 into fx. And I know I get y1 when I put x equals 1 into fx, and that gives me my minus 1. You agree?
Yeah.
Is that okay? Let's now switch from numbers to letters. Pretend now, let me just rub these points out, and let me use instead let me just use x, and my y coordinate will be fx. And then I've got this little gap here. Let's call this our change in y, and this one here will be a change in x. Okay. Now we know from the x to go to this next point here, we added what? What's the change in x? We added 1, isn't it? So we could write this as x plus 1. Okay, so this delta x is really just x plus 1. And then my y coordinate will be what? Plus 1. Okay, so what we're saying is point A, we're just going to generalize now, rather than use 1 and 2, etc. as our, rather than use numbers, we're just going to use a bit of algebra. Okay? And what we're saying is the x coordinate and the y coordinate are written as x plus fx, x and fx, is that okay? And then there's some distance away, there's another coordinate. And the way we can write that is, well, whatever distance this is 2, this is 1, 2, and this is 1. So the difference here is 1. Agree? The change in x here, change in x equals 1. And this change in x is, change in y, sorry, is 5. Yeah? And so what I've got is the change in x plus 1 as my new x coordinate. And the y coordinate would simply be, well, inside fx, instead of putting x, just put x plus 1. In other words, if this is 2, put f of 2. Yeah? Is everyone convinced with this line here? This f2 take away f1. So if you put if you put 2 inside, maybe I should just do this very quickly. F of 2 is just basically saying 3 times 2 squared, take away 4 times 2. 2 squared is 4, 4 times 3 is 12, take away 8, which gives me 4. F of 1 is simply doing 3 times 1, take away 4 times 1, which is minus 1, and therefore I'll get the 4 and minus 1. So all I'm doing is substituting x values inside fx to generate my y values. And in this case, my x value is x, but in the other case, in point B, my x value is x plus 1. And so what I could do, just using some algebra, is simply write this as fx plus 1, take away fx divided by the change in x. The change in x is x plus 1, take away x, which just gives me fx plus 1, take away f of x, divided by 1. And this is your change in y over change in x. Is that okay? But somebody might say, hang on a minute, hang on. We're supposed to be using algebra. Are you always going to add 1? You just said, sir, that the closer the points are together, in other words, the smaller the difference, the more accurate the result. And obviously, if you've got 1, it's not as accurate as if you've got a half, or you've got a quarter, or an eighth, or a 16th. So what happens if you've got a different number? What's going to happen to this equation then? But if you've got a different number, firstly, if you've got a really small amount, we can now use this notation. So for small amounts, infinitesimally small, we can use change in x and change in y. Yeah, that means a very small change. We use delta x over delta y. So we'll write delta x over delta y equals fx plus our change in x, take away fx, divided by our change in x. So in other words, instead of writing 1, all I've done is said, well, it doesn't have to be 1, it could be any small amount, and I'll put delta x. I'm going to take a pause there and just make sure everyone's happy with that before we move on. And it's something you should copy down as... Sorry? Oh, sorry. Yeah, my mistake. That should be delta y over delta x. Thank you. Delta y over delta x. And that's what we say. That difference between the two is a change of x, a change of y over change of x. This is essentially just saying change in y over change in x. That's all that's saying. And that's your gradient. Okay? While you're copying that down, I'll just explain this one more time. If I've got some point A, the coordinate of A is x, the y coordinate will be f of x. I've got a point B. Well, this is going to be slightly away from A, so I'm going to have x plus some small amount it's away from. Then the y coordinate will just be, you take your input, and that will be my y coordinate. And therefore, my change in y over change in x will be fx plus delta x, take away fx. That's y2 take away y1, divided by x2 take away x1. So it's going to be x2 take away x1. And that gives you fx plus delta x, take away fx, divided by delta x. Yes?
So the y coordinate in f of x will always so just be f of whatever x is.
Exactly.
Okay.
Yes. The y coordinate is always generated by simply substituting in your x coordinate inside fx.
Oh, yeah.
That's all you're doing. Yeah, and that's how functions work.
Okay.
Yeah, in 2 dimensions, you've got x, y. You've got a formula. I can say, give me a value of x. Say it's 3. So you do 3 times 2 squared, take away 4 times 3. So you basically substitute in your x value, and out comes your y value. So is everyone okay with that formula so far? Well, that's all that's saying is change in y over change in x using some algebra. That's all that's saying. And the reason why we've got those squiggly delta signs is because we're saying that change is infinitesimally small. It's tiny, it's minute. And we have a symbol for it. It's just called delta. Now, I'll make a side note here, and I'll write down, please note, that some people use delta x, some people might use change in x, or some people the exam papers actually use h as your delta x. They all mean the same thing. But I've used delta x deliberately to emphasize the rules of differentiation, dy over dx. So I'll come on to that in a second. Okay, so all of these are the same thing, and textbooks or examples might use either one. I've stuck with the dx sign, although it's a bit tedious, as opposed to writing h, just to emphasize that it is a small change in x that we have. But in the future, I might not. I'll just stick to h when we do past paper questions. All right, given that we've got this formula, let's now try to differentiate. So let's look at a question. Differentiate fx equals 3x squared take away 4x using first principles. First principles, change in y over change in x. The rule is x plus delta x take away fx divided by delta x. And so this will just be, instead of writing x, I'm going to write down 3x plus delta x squared take away 4 times delta x divided by delta x. Do you agree? Oh, whoops, there's a mistake. Yeah, so that, and then take away, so if I just color code this, so take away my fx, so this part here would be minus f of x, so I've got 3x squared take away 4x divided by delta x. So all I've done is substituted in this, instead of writing x, I've written x plus delta x. Sorry, this is x plus delta x. Is that okay so far?
So what will last bit, sir?
Let's try and color code this. So this yellow part here is this part there, and f plus x plus delta x is this part there. Yeah? Let's now expand this out. Do you want me to use the h letter instead of delta x?
Yeah.
Yes.
Alright. So let's write down 3x plus h squared take away 4x plus h take away 3x squared plus 4x divided by h. So let's write down, let delta x equal h. So we'll just use the h notation.
Why take away the 3x squared plus 4?
The yellow part. So which one are we talking about?
The last bit.
On the right, which is 3x squared minus 4x.
Yeah.
Yeah, why
Oh, because that's minus fx. 3x squared take away 4x. Yeah, this is fx. So fx is 3x squared take away 4x. Look at the formula. It says fx plus delta x take away fx divided by delta x.
What's the bit before that? Minus 4.
This part here.
Yeah, was that all in the first bit?
Yeah, this is fx plus delta x. Yeah, instead of putting in x, you put x plus delta x.
Okay.
If we were to expand this out, x squared plus h will give us x squared plus 2xh plus h squared times by 3 minus 4x minus 4h, take away 3x squared plus 4x divided by h. Is that correct? If we tidy that up further, we get 3x squared plus 6xh plus 3h squared. Can you quiet down, please? Right. If we then cancel out, so the 3x squared and the 3x squared cancel. The 4x here cancels with this 4x. And we're left with 6xh plus 3h squared divided by h is your change in y over change in x.
Minus 4. You missed 4.
Sorry? Minus 4h. Now remember, if h tends to 0, do you remember h is our, what does h mean?
Change in x.
And remember what we said, if you don't follow this argument, you'll be missing out. We said our change in x, as it becomes smaller, it becomes more accurate. So to make it an exact value, we can make our change in x 0. As this tends to 0, what's going to happen? Oh, let's just tidy this up. So that will be 6x divided by h, which is 6x, plus 3h squared divided by h, which is h. Take away 4. So if h becomes 0 in here, what are we left with?
6x minus 4.
6x minus 4. And because it's no longer an approximation, we can now write this as dy over dx. So what we can say is delta y over delta x leads us to dy over dx equals 6x take away 4. Why? Because the h part has just become 0.
So can you manipulate h like that at any point?
It's just to manipulate h like that.
Yeah, like can you just do that?
Do what?
Or is there a rectangle for it? Like can you just set h to be 0?
Right, so what we're saying is, as h tends to 0, because it is a variable, it does mean delta x. Yeah? So we're saying as it tends towards 0, you'll end up with this. Just to double check and just make sure everyone's happy, when I say fx, okay, look, when I say x equals 1, what does y equal to? How do you work out what y equals to at this point? You substitute 1 in, okay? So I'll do 3 times 1 squared, take away 4, which is minus 1. So all I'm doing is substituting the 1 in. If I say, alright then, what about when x equals some letter a? What would my y be then? F of a, which is 3 times a squared, take away 4 times a. What if I say my x, let's just call it, what if I say my x is some value of x plus h? What do I substitute in? X plus h. Which will then give us 3x plus h squared, take away 4x plus h. And that's all that's happened. If you go back and look at this rule we've had here, we're doing y2 take away y1 divided by x2 take away x1. The x2 take away x1 will always leave you with that change, that h. Alright, what I'd like you to do is, given, I'll write this down, dy over dx equals, let's use the h notation because you know what it means. And let's do that. So there's our rule for differentiating from first principle. Can you differentiate the following? Okay, differentiate using first principles the following. Number one, let's do fx equals 2x squared take away 4x, and then let's do fx equals x cubed take away 3x. Yeah, that should be fun. X cubed take away 3x. I think that can. Obviously, you could do it, but have a go at doing it using first principles.